Let's take a look at one example here. This example says, well, do we have a conservative vector field or not? Suppose you have f of x and y equals to, the very first component is x minus 5, and the second component is x minus 2. Suppose this is a vector field. Is it conservative? Very good. So take a look at this. The first component is your P. The second component is your Q. Just need to take the partial derivative and check to see if they are equal to each other or not. So partial derivative of P with respect to Y is equal to -1, and partial derivative of Q with respect to X is equal to 1. So obviously they are not equal to each other. So we're going to say, okay, it is not a conservative vector field. So F is not a conservative vector field. Let's take a look at another example. Suppose you have another vector field. Suppose g of x and y is equal to, the very first component is 3 plus 2xy, and the second component is x squared minus 3y squared. What about this guy? Is this conservative? So the same process. This is your P, and this is your Q. Partial derivative of P with respect to y is going to be 2x. Partial derivative of Q with respect to x is also 2x. They are equal to each other, so we have a conservative vector field. So yes, it is a conservative vector field. Later on, I'll show you how to find function f that the gradient of f is equal to vector field.